This recording is meant to be a review of Chapter 10 in your physics book, more specifically Section 10.2 on mechanical advantage. So you should have already read this section. This is just meant to be a summary, and then I'm solving problem number 27, which is the pre-lab for the pulley lab you'll be doing in class. A machine is a device that makes it easier to do work. And one thing that you want to make sure that you remember is that you can never get out more than you put in to a machine. So output work can never be more than input work. So when you're solving these problems, that's a quick check to see if you've done things correctly. The effort put into the machine is called an effort force. We will mark that with the letter F for force and put a subscript E. And that's the effort that you are putting in, specifically for this lab. However much force you are putting into moving the pulley system, that's your effort force. The force by the machine is how much is being resisted. So that's the resistive force, and we'll mark that with a subscripted R. And the mechanical advantage of the machine is then just a ratio of those two things. How much the machine is resisting as compared to how much effort you put in. So mechanical advantage can be shown by the equation that's here, force resistive over the effort force. Now the problem that we're going to solve today is number 27. It's in your book. The iBook, it's on page 669. It's in chapter 10.2 in the actual physical book. The diagram is here in the corner. And the first part we're going to solve is what the mechanical advantage of the pulley is. So the first two things that we need are we need the resistive force and the effort force. Well, the effort is how much we are putting in, how much we're going to exert to move this box or this crate. So you can see if you read the problem here that 129 newtons is the amount of force that the worker is using to actually move this crate. So we can go ahead and mark our effort force as 129 newtons. Now, how much is this being resisted by? Well, it's being resisted by the weight of the crate. Now, do we have the weight of the crate? We do not. What do we have? Well, we have the mass. We have the mass of the crate. So ask yourself, how do you find the weight of this crate if you have the mass? We're going to go ahead and take your mass times gravity. So we'll take 24 kilograms, and I'm going to just use 10 for gravity. 240 newtons. So your resistive force is the weight. So there's the two numbers that we have, and then you can go ahead and solve for mechanical advantage by taking your resistive force, 240 newtons, divided by your effort force, 129 newtons, and we get 1.86. Now, you'll notice if you have newtons divided by newtons, there is no unit left because mechanical advantage, again, it's just a ratio. So there's no unit with that number there. Mechanical advantage of 1.86. The second part of the problem asks to find efficiency. But before you can do that, you need to find the ideal mechanical advantage, which has to do with how far the machine is moving. How much rope do you need to pull, and how high off the ground does the actual crate go? The ratio of those two numbers. And so again, if you read in 10.2, you can get more information about ideal mechanical advantage. But here are the variables that we're looking at. Your displacement of the effort, how much effort you're putting in, how much rope you are actually pulling, and then the resistive displacement, how much the crate actually lifts up. So the ideal mechanical advantage is the ratio of those two things, the effort to the resistive force. So the first thing you need to do to find efficiency is first you have to find your mechanical advantage, and then you need to find your ideal mechanical advantage. So let's go ahead and do that. Your ideal mechanical advantage is going to be your effort distance. Well, if you take a look at the diagram, this is how far you actually pulled the rope down. So your displacement for the effort you put in, 33 meters. And then the resistive, or how high up the crate got off the ground, is 16.5 meters. So to find our ideal mechanical advantage, you find the ratio of those two things, effort to resistive force, so you have 33 over 16.5. Again, there's no unit for these. And we get an ideal mechanical advantage of 2. So to find our efficiency now, we're going to take a ratio of those two numbers. And if you look back on this video or remember from what we just solved a minute ago, our mechanical advantage was 1.86, wasn't quite 2, and our ideal mechanical advantage was 2, which gives us an efficiency of 93%. And that's how you solve that problem. You should be able to go ahead and move on now and do the pulley lab. It takes you through basically the same calculations.